Yesterday, we encountered the fundamental theorem of calculus for line integrals. After some bit of setup, that just means all the things are going to work. The integral over some path from point P to point Q of a gradient field is just going to be the difference in the endpoints of the potential function. Difference in the potential function at the endpoints. I might have had my prepositional phrases in the wrong order. So when we have a gradient field as our vector field, then we can just evaluate the potential function at the endpoints. This is very similar to our fundamental theorem of calculus, where if we integrate from a to b, a derivative, we just evaluate the function at the endpoints. Any questions? An important thing to note is that if a vector field is path independent, then it is a gradient field. So path independent is just describing our ability to do this. And if we can use the fundamental theorem of calculus for line integrals because our vector field is path independent, then it must be a gradient field. So there must be some potential function. So if a vector field is path independent, then it is a gradient field. So if a vector field is path independent, if it does not matter what path we take from point P to point Q, then we would say that F is path independent. And if the vector field is path independent, then F is a gradient field. That is, there is some potential function little f. My little f's look way too much like big F's. Little f, such that f is the gradient of little f. If a vector field is path independent, then it is a gradient field. So what that means is that some vector fields are not going to be path independent. And so it is going to matter how we parameterize the curve. And we're not just going to be able to find a potential function and subtract at the endpoints. Any questions? One thing that we get out of this is if we have, if we calculate a line integral over a closed path. So if C is a closed path, that is from point P to point P, then our line integral is going to be equal to 0. Then the integral over C of the gradient f dot dr will be f at P minus f at P, because we have a closed path, and so we'll end up with 0. So if we just go around a loop in a vector field, then our line integral is going to be 0. Any questions? Comments or snide remarks? All right, let's pause the video here and talk about point P to point P means just where our starting point and ending point is the same. So we have start at point P, and we follow some path around. So whatever shape this is, if we do a line integral over this curve of some gradient field, then we're going to get 0. All right, so let's pause the video here and talk about what's next.